Hey, and welcome back to another video. In today's tutorial, we're going to cover off how to animate your Matplotlib graphs. By the end of today's video, you're going to be able to create this beautiful animated population pyramid using population data from Canada or whichever data set you want to use. Let's dive right in. So the first thing that we're going to want to do is actually download the data that we're going to be using for this tutorial. So I'll provide a link to this data set in the description below, but it comes from Statistics Canada. You can download it for free through there or use your own data set. So let's take a look at what this data actually looks like. So what we can see right off the bat here is that we have 4 columns. We have a column representing the age group, the year, population for males and for females. One of the things that you'll notice is that we have all of these gaps here. So for example, this population 0 to 4 is actually represented all the way down until the next age group is hit. We can also see that we have commas in between our population values here. And so we'll need to double check that when Pandas imports our data, that we're actually able to load these values as integers rather than as strings. So let's dive in and load our data set. So we're going to take the path to this file here so that we have it easily accessible. And so what we're going to want to do here is first import the libraries with which we're going to be working. So we're going to import pandas as PD, and we're going to import pyplot from Matplotlib as PLT. So let's start there and we'll import additional packages as we need them. So we're going to create this variable here called file path, which is just the file to the file that we just looked at. So let's load this into a data frame and see how we can clean up our data based on what we just discussed. So we're going to create this pandas data frame df, and we're going to use the read csv method here function. So what we're going to do is just pass in our file path parameter, and then let's take a look at what this looks like when we run it. So we can see here that, as expected, we have a ton of missing values, and right now these are actually formatted as strings, and we can confirm this by running the info method. So we know that now we actually know that these are strings, so we'll need to convert them into integers first, and we'll need to deal with the missing values as well. So let's deal with the missing values first. And so what we're going to do actually is look only at the age group values here, because they, as we can see here, are the only values that have missing values. So we're just going to use this age group series here, use the fill in a method. But at this point you may be wondering, how can we fill it in properly? One of the neat things about this method is that it actually accepts this method parameter. And so one of the options that we can use for this is this forward fill method. What this is going to take is take that first value and fill that all the way down until it hits a non-null value. So now let's take a look at our data frame again, and we'll just print out, say, the first 10 rows. We can see that that's actually happened here. So all of these values have been neatly filled down until that next age group's hit, and then all of those values will continue to filter down. So now that we have that fixed, let's actually convert these values here to integers. The way that we can do this is by replacing the comma and then casting it as a different type. So what we're going to do is call this df males and just access that one column. We're going to use the string.replace method here, and we're going to replace a comma with nothing. And then we're going to use the asType function and cast it as an integer. So we can actually copy this down and then simply access the exact same thing for the females column. So now when we run this, we can see that these are actually nicely formatted as integers. And in fact, let's double check our data types and missing values again using the info method. So we can see here, age group is still a string, but it's no longer missing any values. And our populations for males and females are now integers. So let's talk about how we can actually create an animated Matplotlib graph. And so Matplotlib actually provides a number of really helpful helper function or classes in order to be able to do this. One of these is the func animation class. So let's go ahead and import this. So we're going to say from matplotlib.animation, we're going to import func animation. We're also going to import this pillow rider class, which will allow us to export our resulting animation into whatever format we want. So the way that this func animation class works is you pass in a figure and you pass in a function. And so the function here is actually what's used to create different visualizations, which Matplotlib will then animate by cycling through them. We can also talk later about some of the additional parameters, such as passing in frames, which will determine how quickly our animation moves. So really what we want to be able to do first, now that we know that really what we're doing is cycling through a bunch of different visualizations, is set up a base visualization. And the easiest way that we can do this is just by filtering down into a single year. So let's create this first filtered data frame so we can create a base visualization of how each of the resulting animations should actually look. So we're going to create this data frame filtered. We're just going to access a single year in here. It doesn't matter which year, it just needs to, of course, exist in the data set. So we're going to access this value here. And so once we have this, we've filtered down our data frame to only include the populations for each age group for the year 2000. So let's go ahead and print that data frame. So when we run this, we can see that indeed it has filtered down only to the year 2000 here. So let's go ahead and set up a base visualization that we can then use to replicate based on that figure that we pass into the func animation class later on. So what we actually want to do here is create a figure and an axis object. So we can do this using fig and ax, and we'll use the plot.subplots function here. And let's give it a figure size just so we can set that more permanently. And for this, we're going to use 15 by 8 inches. So let's take a look at how we can create this population pyramid. When we talk about a population pyramid, really what we have on this side, are two different horizontal bar charts, each starting at the value of 0. So this middle line here actually represents the value 0. On the right side, we have the population for males, and on the left side, we have the population for females. So let's take a look at how we can first plot just the population for males. So what we're going to do is use the plot bar h function here. We're going to pass in the value for y, which in this case is going to be the age group. And then we're going to pass in a value for x here, which in this case is going to be the population for males. So let's go ahead and show this. So actually in this case, the x parameter isn't x, but it's width. So when we run this, we can see that we get this visualization here, which right now is quite large. So what we have here actually is all of the populations just for the year 2000, just for males. So now let's add in the female values here. So we'll just copy this line down and change it to females and just run our code again. So what we can see here is actually that the values have been overlaid. So this is because we first plotted the values for males and then we plotted the values for females on top of that. But what we actually want is that the females show up on the left side of the graph so that we get this nice spread of values for the different genders. So what we actually need to do is in our data frame, we need to multiply all of the population values for females by -1. So let's go ahead and do that here. So we're gonna access again the females column, and we're just gonna multiply this here by -1. So this will flip all of those values to be mirrored on the other side. So let's just see whether or not this worked. So we can see now here that we actually have that spread exactly how we wanted it, right? So what we can do now is just style our graph in a bit of a meaningful way. So some of the things we may want to do is remove the spines of our graphs. We'll want to remove or modify some of these labels down here. Right now they're in scientific notation, which isn't really intuitive for a lot of people to read. Another thing we'll want to do is modify the colors so they're a bit less generic, and we'll want to add in some data labels and of course a title. So let's go ahead and take a look at how we can do some of this stuff. So the first thing we're going to want to do here actually is pass in our data labels. So Matplotlib has made it tremendously easier than it used to be to actually add values to a data label. And so the way that we can actually do this is by accessing this ax object again. And what we're going to do is pass in this bar label method here. And so what this actually expects is a container. And right now, neither of these method calls here, or function calls, are actually contained in anything. So what we can actually do here is call this using the variable males and females. And so now, for example, we can pass in the container males. And what we want to do here now is when we take a look at what this looks like, it's actually added in all of these values here. So actually one of the things we need to do here is change all of these references to our filtered data frame. So when we run this now, we can see that we actually just have the single value here. So we can customize this a little bit further by adding in a little bit of padding, as well as changing how these labels are represented. Some of the changes we may want to make is adding 1000 separators for some of the 1000 values, as well as rounding them a little bit. We don't actually need this level of precision. So let's take a look at how we can do this. We can go back into our bar label method call here and add some padding. We'll pass in the value of 3 and take a look at how this looks. And then for our labels, we can actually pass in a list of labels that we want to display here. So the way that we're going to actually create these labels is using a list comprehension. So what we want to do here is actually access each value for the value in filtered males here. So right now, this is just going to return the exact same value that we currently have. But what we want to do is actually format the output value here. So let's wrap this as an F string here. And what we're going to do is actually format this in a different way. So we're going to pass in the round function, and we're going to use a negative value here. And that's really just going to round it to the nearest thousandth here. And then we're going to format this using this neat string formatting method, using the comma here, which is going to add in the 1000 separators. So let's run this and take a look at what it looks like now. So we can see that our values are rounded to the nearest 1000 value, and we've added in the comma separators as well as a bit of padding here. So now that we know that this worked for one series, let's do it for the other one as well. So we can just go ahead and copy this down and apply it to the females container here and change our reference here. So when we run this now, we can see that it looks almost there. We're noticing that these values are negative, remember, because we multiplied all of our values by -1. And some of these values here are overlapping with our actual axis. So we'll take a look at the axis after, but first let's format these as positive values. So because we're labeling our values directly, we can actually just multiply the resulting value here again by -1. So that's going to turn the negative values into a positive value. So we can see here that all of these values are now positive again. So let's take a look at some of the axis options that we have now. So what we can do now actually is remove all of the spines around it. So we're going to do this by creating a for loop, and we're going to pass in all of the different edges that exist. So we're going to say top, right, bottom, and left. And then we're going to access each of these different edges in that for loop. So we're going to say ax spines. We're going to pass in just our edge here, and then we're going to apply the set visible method here and set it to false. So what this does is it's going to loop over each edge and just remove that line here. So this already looks a little bit cleaner, but we still have a bit of cleanup to do here. We may also want to actually remove all of the tick marks here so that it just looks a little bit cleaner. So the way that we can actually do this is by accessing the tick params attribute. So we're going to type in ax.tickparams, and we're going to say left is equal to false here. So when we run this, what we get back is just the labels here without that little dash. We still want to make sure that all of these values don't actually overlap. And the way that we can do this is by changing the width of the minimum and maximum values in our graph. So let's go ahead and do this. So the way that that's done, and we want to define this a little bit further up, is actually by accessing the set xlim method here, and we're just going to pass in just from 2 million to positive 2 million here. And so let's take a look whether or not this is wide enough now. So we can see that no longer are the values overlapping. And really what we've done here is taken a best guess that none of these age groups are going to be over 2 million, and we'll be able to verify this once we start animating it. So now that we know that none of these values are overlapping, let's go ahead and change our axis down here to be invisible, because we actually have our data labels down here. So the way that we can do this is actually, what we can do down here is use the get x-axis method, and we're going to apply the set visible method here and set it to false. So when we run this, we can actually see, when I zoom out a little bit, that we no longer have the x-axis. So now our graph is already looking quite a bit better. Let's take it a little step further and add some color as well as a legend, because right now we can't tell whether or not these are females or vice versa. So the way that we can do this is actually changing the values in these containers here. And so what we're going to do here is pass in a color value. And so this either accepts a name color or a hex color or many different options, but let's work with some predefined colors here. And so we're going to pass in this hex value here. And similarly for females, we're going to pass in this value here. So let's take a look at what this looks like. This looks significantly better in my opinion, but we're still running into the issue where we don't know which gender is which color. So what we need to do is add in a legend. So let's go ahead and add in that legend now. All right, so to add our legend, what we're going to do is use the axLegend method, and we're going to say that we want the values for males and females, and we want to assign them the values males and females. So let's take a look at what this looks like. And if I zoom out a little bit, we can see that we now have this nicely formatted legend up here. So our last step in terms of setting up the shell of our animation is actually to add a title. So let's go ahead and do this now. So what we're going to want to do is pass in ax set title. We're going to pass in a string here. So we're going to say population of Canada in 2000. And we're going to pass in a size of 18. And we're going to pass in a weight of bold just to make its style a little nicer. So this now gives us this really nicely formatted title here. So let's take a look at how we can animate this now, because really that's where things start getting really fun. So recall that we imported this func animation class here. So what we have to do now is pass in a figure object, which we've already created, and we need to pass in a function. And so the function gets called at each frame here. So really what we want to do is cycle through all of the different years in our larger data frame DF and create different figure or different visualizations off of that filtered data frame in the same style, and loop through that using this func animation class. So let's take a look at how we can do this. So we'll go here and we'll just remove the show call for now. We're going to create an animation object here, and we're going to call or instantiate this func animation class. So what we need to do is pass in our figure, and now we need to pass in a function. So we don't yet have a function, so let's actually take a pause from this and create it. So all of this code that we did here to be our shell of an animation, what we want to do is actually put that into a function. So we can indent this and then just create a function here, and we'll just call this animate. And so our animate function here is going to take a single parameter, the year by which to filter it. So we're going to pass in year here. So now as we filter down our data frame, we're actually able to filter the data to different years within our broader data set. So we actually want to be able to move this filtering into here as well. So now we can actually replace this value here with our year parameter. Remember that we hard-coded in the value 2000 here as well. So what we can do is change this to an F string and just pass in that parameter. So what we get now is we can actually pass in our function animate here, and we're just going to pass in the function object, or the callable, without the open and closing parentheses. So now the last thing we need to do is actually pass in the frames that we're going to use. And so the frames we can think of as being the values that get passed into our animate function in order to be able to speed things along and generate new images. So to do this, we're going to create another list of values here. So we're going to use the range function to define from which year to which year we want to be able to create these frames. So we know that we can access the min value in our data frame here rather than hard coding the data. And we can also access the max value. Now, because we want to include the maximum year, we actually need a value of +1 here. So let's take a look at what this looks like when we run the plot.show function here. So we can see that this actually still has a little bit of work that we need to do. Right now, it's not actually overriding a lot of the data here, and it's looking a little clunky, to be honest. So what we need to do is actually pass in this ax.clear function here, or method. And when we run this, it's going to clear the axes after each frame and be able to override or rewrite that axis object with new data. So now we can see that it's cycling through each of the years in our data frame, creating this beautiful population pyramid that's animated. So when we zoom out a little bit, we can actually see that we have a nicely formatted title, which is dynamic and responsive to the year that's being filtered to. We have a legend here that clearly describes what gender is being considered. We also have our y-axis here showing the different age groups, as well as neatly populated rounded values for each of the populations. So the last thing that we're going to take a look at is how you can actually save this. So let's go ahead and remove this function call here. And all we need to do now is use that pillow writer class that we imported before. So we can say animation.save, and let's give it just any name here. So we'll call this population pyramid.gif. And we're going to say we want it at a nice and high DPI. And we're going to use that pillow writer class. And at this point, what we can actually do as well is set a frames per second. So the way that we can think of this is how many different graphs should be generated every second. So let's go ahead and just give this the value 5. And let's actually save this also to my desktop. And so when we run this, what we get back is on our desktop, we now have this population pyramid. What we get back is this beautiful population pyramid that's animated over the different time periods. So I encourage you to play around with your own data and see how you can animate data visualizations in really meaningful ways that really highlight differences in data over time or in different ways to be able to really amp up your data visualization in Python. I really hope you enjoyed today's tutorial. If you did, please hit that like button. If you haven't yet subscribed, consider subscribing and hitting the little bell icon to be notified of when I release new videos just like this one. Thanks so much for watching, and have a great day.